Okay. Now see this truth, right? Now we have to discuss about these alpha, beta, gamma rays, right? Last week, finally, we stopped with this alpha, beta, gamma, right? Finally, we stopped with this alpha, beta, gamma. Now, okay. Now, Buddha, now I said there are three parts, right? Last week, finally, we stopped in this part. I said there are three particles. What are those three particles? There are three types of emission from a radioactive substance. And I told these radioactive substances are stored in what? Inside a what? Inside these radioactive substances are stored inside a what? What did I tell? Inside a inside? Hmm? Inside lead, right? Inside lead. So from this radioactive substance, there are three types of emissions. There are three types of emissions from this radioactive substance. Right? This is a radioactive substance, and I told there are three types of emissions from this, right? Then what are those three types of emissions from this? One is speak. One is loudly speak with it. Alpha, can kata karan. Alpha, beta, and gamma. Right? There are three types of radioactive emissions. Now, and I taught you, right? Last week I told you what is alpha means. I said alpha, this is alpha. Alpha, how we write? This is 4, this is 2. Normally, what we say for this, the bottom one as the atomic number, the top one as the mass number. Normally, we say this one mass number, this one atomic number, right? We tell that. So, and I told this is something like, this is equal to, I said, helium nucleus. Helium nucleus. Alpha is equal to helium nucleus. Again, helium's nucleus, not the entire helium atom. Helium's nucleus. Helium nucleus mean what? It is without what? It is without electron. It is without electron. So helium nucleus is a thing without electron. So the electrons natuwa තියෙන එක. So no electrons in this. So in alpha there is no electron. Then beta. Beta I told. Beta we can write 0 minus 1. So I told this is like electrons. Beta is something like electron. Okay, this is equal to electron. And gamma mean, I said, these two are particles and gamma is an energy. So I told you these things, right? Alpha and beta are particles and gamma is an energy. So these things we did last week. Last week we ended with this. Today we have to speak several properties about these things. We have to speak about the properties of this. Then බලමු කොහොමද මේකේ properties යන්නේ කියලා, right? How the properties changes. Right. Now, Puta, now it's not time to write. Work either. Right. Do you do something else? No. You do a business. You do only studies. You're working also. Right. Okay. Now, see this part. Now, there are three types of substance. One is, there are three types of substance, alpha, beta, gamma. Now, we have to speak first about their properties in the electric field. The first topic is electric field. Is it? Right. In electric field, what will happen? Now, I'm sending this alpha, beta, gamma in an electric field. Alpha, beta, gamma. Right. I said this is stored in some, what is this? Lead. Normally this is stored in lead. Okay, then only these radioactives won't go away. Radioactive emission means that they start to fade. They start to fade. That is only radioactive emission. It means they, after some days they will vanish. After some days they will vanish. That is only radioactive emission. Right. And they are sending this alpha, beta, gamma rays like this. These are the three types of emissions going like this. This is alpha, this is beta, this is gamma. We'll send the gamma in the middle. Right. So this is the now three types of radiations are going. Now you are keeping an electric field in between this. You are keeping a plus terminal and a minus terminal like this. This is the plus. Right. Okay. And we'll say this one is minus. This is a minus terminal. And I told you, did I tell that? Alpha is positively charged. Why alpha has 4 2? 4 2 means it has only protons. Protons and neutrons. I said no electrons. So what are the subatomic particles alpha has? Protons and neutrons. Therefore, it should be what charge? Positive charge. So don't try to by heart, try to understand. It should be positive charge. I said beta means 0 minus 1. And I said this is like electrons. Therefore, it should be what charge? Negative charge. Gamma, I said, it is an energy. So energy, do they have a charge? They are neutral. Okay, so I have to write this as neutral. This is neutral. Now, there are three types of emissions, right? Is going from this. So when they meet this plus minus, what will happen to them? We'll see. Now, these radiations will continue like this. Okay, this is alpha, alpha, beta, and this one is gamma. Right? Okay, gamma, right. Now, first gamma is charged in neutral. Therefore, what will happen after this? It will start to travel in the same pathway. It will go straight. Nothing will happen to that. It will just travel straight. Like no charge, so no effect from this electric field. Now this is what charge? Alpha, positive charge. Therefore, what will happen to that? It will start to turn to negative side. Start turn to negative side, like this. Okay, after this, when they are coming towards this, start to turn to negative side. Beta, what will happen? To start turn to negative side. Okay, right. What will happen to beta? Beta start to turn to which side? It will start to turn to positive side. Positive side. Right. You have to draw like this. So this is the way how they travel. Okay. How alpha, beta, gamma travels once they meet the electric field. Right. Okay. Now we have to write a note like this. Okay. What is the note? We have to write the note for effects on electric field. Then effects on electric field, under that you can write Puta. Alpha rays are write like this. Alpha rays are alpha rays are positively charged particle. Alpha rays are positively charged particle. Therefore, 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 it will deflect. Therefore, it will deflect. It will deflect to the negative plate. It will deflect to the negative plate of the electric field. It will deflect to the negative plate of the electric field. Okay. It will deflect to the negative plate of the electric field. So you can see that. Next one, you can write. What you should write next? Which chapter? Beta is negatively charged particle. Therefore, it will deflect to the positive plate of the electric field. Right? Again, whatever we told earlier, beta you should write the opposite thing. Okay, right? Good. Now, write the next point. Gamma is an energy. Gamma is energy. Gamma is an energy. Gamma is an energy. Therefore, it is neutral. Therefore, it is neutral. Therefore, it is neutral. So there is no effect. So there is no effect from the magnetic field. Therefore, there's no effect in magnetic field. All right. So when you expose a gamma to a magnetic field, so you don't have any what deflection. So it will go straight. All right. The maker you have to draw. And I'll draw something else. ඒකත් බලා ගන්න මොකද්ද මේක වෙන්නේ කියලා. So can you see this deflection? From this deflection, all right, which is turning more, beta or gamma? Who is turning more? You can see this picture and tell. Who is turning more according to this picture? You don't speak. Who is turning more? Beta is turning more. Beta turning this much. Alpha is turning only this much. So when you make a circle with alpha, you make a full circle. If you make this deflection as full circle, alpha will make a large circle. Correct? But beta will make a what? Small circle. Therefore, if I tell this one is beta's radius, and if I tell this one as alpha's radius, if they make a circle, these are radius. Whose radius is more? Radius of alpha is more than the radius of beta. So if I call this as the deflection, this is, I said deflection. By deflection, they will make a circle. Therefore, I will call these things as deflect radius. What again? Deflective radius. So deflective radius of alpha is greater than deflective radius of beta. Deflective radius of alpha is greater than deflective radius of beta. Right like this. deflective radius, yeah, under the effects on magnetic field, under that same thing, you can write like that. Deflective radius of alpha is greater than deflective radius of beta. Deflective radius of beta. All right. Now what you should do, now already you have this diagram already in your book. There, right? Already it's available in your book. So no problem. Then what you should do, you have drawn only this circle. The circle දෙක දාගන්න ටක් ගාලා. Put those two circles. ඉක්මනට දාගන්න. ටක් ගාලා දාන්න. Now we are talking this under subheading effect of alpha, beta, gamma on electric field. හරිද? Okay. Now observe. Now this part is okay now. Now still I didn't teach you what is the reason behind this. නිකම් මෙහෙම why this should rotate in a big circle, why this should rotate in a small circle. There are reasons for that. නිකම් we don't learn things in A level. Most of the things we give reason. There are some areas we tell no need the reason. You just know these things here. But here you should know the reason why this goes like this. Know that. Now, Buddha, we have learned a thing called EM ratio. Yeah, we have learned a thing called EM ratio. Can you remember EM ratio? We learned something called EM ratio. No, Buddha? We learned this for electron. But everything we can write as an EM ratio. Everything. If there is a particle with a charge, you can write as an EM ratio. Why that particle will have charge. That charge will write in coulombs. And there is a mass for that. We'll write that mass in kilograms. We will get a EM ratio for it. Then, Buddha, remember, when you take alpha and beta, who is more heavier, alpha or beta? Who is more heavy? Alpha is heavy. Why you are telling alpha is heavy? Because why you are telling alpha is heavy than beta? Reason? Alpha is big. You see? What the reasoning? Why are you telling alpha is heavier than beta? Reason? Because alpha is 4-2. Beta is 0 minus 1. So alpha has 4 neutrons. Can you remember neutron, proton, electron? Out of this, which one was the heaviest particle? Neutron was the heaviest particle out of all three. Then proton, then electron. So beta mean it has only one electron. Beta particle mean what? Only one electron. That's why we are writing beta 0 minus 1. But when you take alpha, how many protons in it? 2 protons. How many neutrons in it? 2 neutrons. How you say 2 protons and 2 neutrons? Because when you take alpha, Buddha, how you write alpha? Alpha 4-2. What is this 2? Protons. This is 4 mean this 4 is made out of proton plus neutron. If proton is 2, neutron also should be 2 here to get 4. Can you understand? Good. So beta mean we write 0 minus 1. Therefore, you can say first point, okay, mass of alpha is greater than whom? Greater than beta. Because why? Because alpha is made up of what? Two protons and two neutrons. You write it completely. I have written shortly 2p and 2n. When you are writing, you have to write it completely. Beta is made up of one electron. So you can, the mass of alpha is greater than beta. Okay, my question is, then whose EM ratio should be more? Alpha or beta? Now alpha has how many charges? Alpha has protons. Beta has only one electron. Neutron has no charge. Likewise, the charge will be double in alpha. Beta's charge will be x. Beta's charge is x, mean alpha charge is 2x. But when you see the heaviness, alpha is much heavy than beta. Why? It is made out of two proton, two neutron, or heavy. Electron it is made out of only one electron. Electrons, more than electrons weight, proton and neutron, patta weight. This alpha's weight is patta high. Whose EM ratio should be small? Think and answer. Alpha's EM ratio is small or beta's EM ratio is small. How's whose EM ratio is small? That's my question. Alpha or beta? That's right. Your answer? It'll again now. You should be able to think. Ageda adu EM ratio එක. Whose EM ratio is low? Who? Beta's EM ratio is low කියලා දවා කියන්නේ. Right. හැමෝම එහෙම. Alpha. කියන්න මොකක් කරන්නේ? You should be able to think and answer because you should work out your brain. With your brain, you should be able to think. හැමෝම කියන්න මොකද්ද? Who is small? EM ratio small? Beta. ඔයා? Beta. Beta වල හිතලාද කියන්නේ? Yeah? Beta's EM ratio is small. Alright. Think, but if you think මෙහෙම හිතලා බලන්න. يعني when you are thinking your thinking ability is low කියන එක මේකෙන්ම තේරෙනවා. يعني thinking කියන එක you should be able to think. That is the biggest thing. Yani your brain should be like clear. Clearly, you should be able to think with a clear-cut knowledge. The knowledge and name now. I gave all the knowledge what you want for this question. I said no, but make two protons mean. Now, who are having charges? Proton having charges. Electrons charge and protons charge both are same. What was proton's charge? What was electron's charge? 1.602 into 10 to the power minus 19 coulomb. Proton charge also the same thing. 1.602 into 10 to the power minus 19 coulomb. In charge dekama ekai. But alpha's charge is double than proton. Sorry, who? Beta. So we'll think with EM ratio. I'll put the alpha this side. And I'll put beta this side. Again, you should be able to think. මෙතන අපි හිතමු alpha වල charge is 2x. EM ratio මේ charge is up. එතන මේකේ charge එක x. Divide by the mass. Now think how many particles are there for beta? Beta has only one particle. Alpha has how many particles? 4 particles. 2 protons, 2 neutrons. So which one whose EM ratio is small? No? මේක බලලා කියන්න බැරි නම් උඹලා ඉතින් දන්න. Whose EM ratio is small, no? Whose one is small? When you solve this x over 1, when you solve this x over 2. ඒ කියන්නේ XO1 mean X න. This is X, this is XO2. මේ ඇත්ත නෙමේ. මේකේ 4 නෙමේ actually ඊට වඩා වැඩි. Because electrons weight comes as 10 to the power minus 28 වලින් නේ යන්නේ. අර කියන්නේ 10 to the power minus 24 වලින්. හරිද? ඉතින් ඔය පොඩි idea එකක් තියෙන්න ඕනේ. So this is what heavy. It means like electron, what's the mass of proton? Nearly 2000 times. ඒ වගේ. කියන්නේ 10,000 times වගේ වැඩි මේක. 10 to the powers වලින් ගත්තනේ 1840 times වැඩි කියලානේ I told you. Right? Then we did these things last week. So you should be able to think. At least you should be able to think like this. හරියට ඉගෙන ගන්න. අස්සන්. කියන්නේ with the proper knowledge. නිකන් ඔහේ don't try to learn. Can you understand? Although this is double of charge, mass is very high. Therefore, the final answer will be low in alpha. Therefore, alpha's EM ratio will be less than beta. Can you understand that? But actually, whatever I have put here is not exactly correct. This is 2x, this is x is correct. But this is 1, this is not 4. Actually, it's more than 4. This will come something like, I have given charge of a proton when compared to electron. I gave a chart. Chart take charge නෙමෙයි mass of a proton when compared to electron බලන්න 1840 කියලා I have given. It means when you compare to an electron, like an electron 1840 times heavier is a proton. එතකොට කොහොමද weight එක? මේක electron එකක් විතරයි. එතකොට ඒකේ proton දෙකක්ම වෙනකොට කෙලින් මෙතන කොච්චරක් වෙනවද? 1840 is දෙකක්. එතකොට මේක පට්ට බරයි. So when this is what heavy, EM when M's value is increasing, this M's value is increasing when this EM value will decrease. Can you understand what I'm doing? When this M's value is increasing, this entire EM value should go low. So you should be able to answer like that. හරියට හිතලා should be able to answer. ඒ කියන්නේ next point එක කොහොමද ඒක අපි ඉන්න ඕනි පුතා එහෙනම්? EM ratio of alpha for the EM ratio of alpha is smaller than beta. EM ratio of alpha is smaller than beta. Okay. Next point. There is a thing, Puta, when EM ratio is more EM ratio, when the EM ratio is more, okay, if when EM ratio is more, the deflective angle is more. The deflective angle is more. Again, what does it mean by deflective angle? It's turning. This turning is more. Therefore, whose EM ratio is more? Beta's EM ratio is more. Therefore, who will turn more? Beta will turn more. What's the point? So you should give the reasons very beautiful like this. So you have to say, okay, EM ratio of beta is more, therefore beta's deflective angle is more than alpha. Understood? Here is the next point එක මොකක්ද දෙන්න ඕනේ? Deflective angle is more mean what will happen to deflective radius? Deflective radius become small the bigger? Small. When they turn more, they will make a small circle. When they turn less, they make a large circle. When they turn more, they make a small circle. When they turn less, they make a large circle. එතකොට deflective radius go in the opposite way. Okay? Okay. You can write. Therefore, beta's deflective radius is less than alpha. Less than alpha. Do you understand the reasoning now clearly? කොහොමද මේක start කරන්නේ? Mass of alpha is greater than beta because alpha is made up of two protons and two neutrons. Beta is made up of one electron. EM ratio of alpha is smaller than beta. හරිද? ඔන්න මේක comparison කියලා මේක පැත්තෙන් you can write. Okay? EM ratio is more when EM ratio is more, the deflective, okay, the deflective angle is more. And EM ratio of beta is more, therefore beta's deflective angle is more than alpha. ඊට පස්සේ මොකක්ද ලියන්නේ? beta's deflective radius is less than ලස්සන්ට මේ ටික ඔතනට you have to write. Clear? Clear? ලස්සට දාගන්න. Beautifully understand and write this. නිකන් ඔහේ ලියන්න එපා. හරිද? මේක ප්‍රයා කරන එකත් you just write in a corner. ලස්සනට කරගෙන යන්න පුත. මන්ට. Now, online students, did you understand this? Is it clear? Right. Now, good. Now you should write this under, you suppose you should have written this under if deflective angle. Now, next one, effect on magnetic field. Now, what did he do? He did the same thing. He did the same thing under magnetic field. Again, he sent these. Now, this is the lead. This is lead, right? This is lead. From this, there are three types of emission. Now, what he has kept here, a north pole and a south pole. North pole and a south pole. He has kept a north pole and a south pole. Right. Now, normally north pole is which color, Buddha? North pole the blue. Yeah. North south take over the blue. Over the red. What is it? South is red. South is blue. North is red. Are you sure? Yeah. Double check kara. In a magnetic field, in a magnet. Right. Okay. In a magnet, what is blue? What is, okay. Red is north. Blue is south. Okay. Make a north. Make a south. This is north. This is south. This is north. This is south. Now three particles are coming. When alpha. This one beta. Mea gamma. What do you think? What might happen? What might? What will happen to gamma? Gamma will go without any change because it's neutral. When the people are neutral, they don't have any problem. They don't have any problem. They will go even whatever thing. Even electric field, they didn't feel anything. Like they went. But when you are charged, when things are in your mind, when more things are in your mind, you are charged. When you are charged, you will turn to one side. You are turning. Right. But when you are like gamma, neutral, when like senseless, feelingless. Okay. Now, this alpha, what do you think? Alpha will turn to north or south? What do you guess? Yeah, guessing, even online students, you also can tell. What do you think? This alpha will turn north pole or south pole? What do you think? It will turn to north pole. Alpha? Yeah. Alpha, you're telling north pole. Beta? South pole, ever. Right. Alpha is what pole? South pole. Beta? North pole. What do you think? Anyone have any other idea? What will happen, Buddha? Alpha will come like this, and it is not having north pole or south pole. It won't turn for north pole or south pole. It will turn perpendicular to north or south. Again, perpendicular to north or south means it is coming like this, and it will turn inside the board. It will turn inside the board like this. Inside the board. Inside the board can represent like a cross. No? Inside the board, it can represent like now. This will come like this. But it will go inside the board. You understand? මෙහෙම ආපු එක දැන් මෙහෙම ගියොත් now you have to go outside, you have to go backside to see that. And inside යනවා දැන්. මෙහෙම ආපු එක it is going perpendicular to this. Can understand? Then what might beta do? මෙහෙම ආපු beta මොකක් කරයිද? This going inside mean beta also will go inside. එහෙමද? Yeah. Alpha normally positive particle කෙනෙක්. But if he is going inside, beta will come outside. Outside in a කොහොමද I should represent? You know, as science students. Sir එකයි dot එකයි. I should represent with a circle and dot. What does it mean? කියන්නේ මේක දැන් it's coming out. කියන්නේ මෙහෙම ගිය එක්කන දැන් මෙහෙම it's coming out. Can understand that? You learn this when you're doing magnetism. But you have learned this. Why they are representing this cross and dot? What are they thinking? Thinking with an arrow. Arrow. You know arrow? How they make an arrow? Arrow, you have a part like this. Nowadays, you don't use this. Actually, this is fixed like this. One is fixed like this, other one is fixed perpendicular to this. Another line, one like this. When you see from a side view, what you see? Actually, make a idea. Cross you will see. You will leave. Nowadays, no one using this. No, puta. And what use karan? Tell me. Tustamai. Right. Short. They're using this only when someone see the eyes like this. What they see? They see it coming like a dot. Or a dot. You will see. When someone see from this side, from back side, they will see a cross is going away. Right? Going inside, cross going towards us mean dot, going away from us mean cross. With that concept only, they made this dot and cross. Then they after completing all our science. Already we knew this. That's why they are putting dot and cross here. You have done that. You also didn't. Who taught you? Me. This dot and cross when the what? How you finish your A-level science, right? Right? Well, now understood. We'll write like this. And you have lesson. Okay, right? We have write this what? Effects on magnetic field. Effects on magnetic field we'll write like this. Right? Alpha and beta rays. Right, like this. The alpha and beta rays deflects perpendicular to the magnetic field. Deflects perpendicular to the magnetic field. Alpha and beta deflects perpendicular to the magnetic field. Next point. Now, always don't think this alpha will go side, beta come outside. Not like that. It can happen any side. Right? So write the next point. Alpha and beta deflects to opposite sides. Alpha and beta deflects to opposite side. Alpha and beta deflects to opposite side. Alpha to opposites. You are saying two. No, two. TO2 to opposite sides. Again, deflect to opposite sides. මේ පැත්තට ගියා නම් අනිත් එක අනිත් පැත්තට යන්න දෙන්න එකම direction වල යන්න. Right? Next point. But gamma will travel without any obstacle. Gamma will travel without any deflection. Gamma will travel without any deflection. Now understood this? Yeah, for this picture. But even the deflection, right? Okay. Okay, what you can say about the deflection of alpha and beta? Both will deflect in the same way. What put the? Not miss. How? What you can say about the deflection? Will they deflect in the same amount? Oh, the deflection is different for alpha and beta. The deflection is different. It is same way as in the electric field. Then whose deflective angle is more? Beta. Alpha's deflective angle is this. Right. After drawing this, right? Beta's deflective angle is more. Beta's deflective angle is more than alpha. Beta's deflective angle is more than alpha. Beta's deflective angle is more than alpha. No problem in it. Good. Again, passe buta. Now the next thing, the next topic about this alpha, beta, gamma rays, right? The next topic is their penetrating abilities, right? Next topic is penetrating abilities. Now, what is this penetrating ability? What is this penetrating ability? What is this penetrating ability? What do you mean by penetration? What do you mean by penetration? Penetration is a normal English word. Penetrating or penetration. What do you mean by that? What do you mean by penetration or penetrating? Penetrate penetrate means going through. Penetrate means going through. Right? That is only penetrating. Now this alpha, beta, gamma particle, if you speak about the penetrating abilities, normally gamma is an energy, no? So although you keep a wall, gamma will pass this wall and go. No problem for that. If you give a wall, gamma will pass the wall. Gamma, right? So gamma penetrating ability is high for gamma. Very high. Next one, alpha and beta both are there. Both are particles. So they can't penetrate. Listen. Don't right now. Both Lian and never. Now pass that and come here. Listen carefully, then this will go to your head. Otherwise, you have to buy heart. Now I said gamma is an energy, therefore it can penetrate. Even a large doesn't matter. But alpha and beta are particles. So whatever the object in front of them matters for them. Right? Normally penetrate කරන්නේ කෙනෙක් ඇතුලේ යන්න පුළුවන් කාටද? Mostly the people who can go fast. The people who can travel fast. People who can travel fast, their penetrating ability is more. Now gamma's speed is equal to light speed. Gamma is an energy. Normally energy travels in light speed. You know, in electromagnetic spectrum, gamma rays what speed? Yeah, no, what speed? Light speed. Beta mean I said it is like electron. Beta කියන මොකක්ද? Electron. When you take beta, how will be beta speed? Beta is close to this. So when you take alpha and beta, who is fast? Who is fast? Beta is fast. Beta's penetrating ability is more than alpha. Right? Even alpha, actually, you can stop alpha even by a small cardboard. You keep a small cardboard, whatever the board, like the front cover page of your book, even if you keep a cover page in front of alpha particle because that's slow. When the particle is small and when they are speed, they can penetrate. They can penetrate more. Now, why gamma is penetrating very high than beta? Because gamma is an energy, it's not a particle. That's why they can penetrate more. Now, can you understand? Can you remember the penetrating? Okay, earlier we spoke about deflection, deflective angle. Deflective angle goes high with what, Puta? With the EM ratio. When the EM ratio is more, deflective angle is more. When the EM ratio is less, deflective angle is less. When the deflective angle is more, the deflective radius become less, small. When the deflective angle become less, mean deflective radius become large. Get all with the other. Good. Can I understand chemistry? Student can understand. Probably you can understand with the theory. ඒව තමයි අහන්නේ. උඩ කිසිම දෙයකට බය වෙන්න එපා, right? Chem අපි වැඩේ කරමු. So no need to have any doubt in it. ලස්සනම අපි කරලා දෙනවා ඒක. Right. Now alpha beta gamma in this part in the right like this. Now we are talking about penetrating ability. Now the topic is penetrating ability. Penetrating ability. Now we are going to speak about this. Now, under penetrating ability, write the first point. Gamma's penetrating power is very high. Gamma's penetrating power is very high because it's an energy. Because it is an energy. Because it is an energy. Huh? Penetrating ability or power, whatever. I don't. What are the penetrating power? Okay, penetrating ability of power. Penetrating ability of gamma ray is high because it is an energy. I got because of energy. Very high. Second point, when the particle size becomes small, Next point, when the particle size becomes small, when the particle size becomes small and speed become large, when the particle size small, the speed become large, the penetrating ability increases. The penetrating ability increases. The penetrating ability increases. Beta is smaller than alpha. Beta is smaller than alpha. And beta is faster than alpha. And beta is faster than alpha. And beta is faster than alpha. Therefore, beta's penetrating ability, beta's penetrating ability is more, beta's penetrating ability is more than alpha. Alpha's penetration can be stopped even by a tiny cardboard. Okay, even by a tiny cardboard you can stop the alpha. So you can write penetrating ability කියලා දාලා alpha beta gamma කියලා. Right, this gamma is very large, beta ඊට පස්සේ alpha is very small. You all can understand, right? මේන ලොකු scene කියලා හිතාගෙන don't try to learn මේ පොඩි MCQ points. චුට්ටි MCQ points. To understand and learn. ඊට පස්සේ I no need to buy hard. ගාන්න දැම්මෝක save වෙන ඕනේ. Okay, mu energy is always penetrating. Beta is bend fast. Therefore, it can penetrate. Alpha is slow. So penetrating is slow. Harida. Very good. Now we are going to speak about the next property. What the next property? Ionization power. Very good. Ionization power. Ionization power. Now we are going to speak about this ionization power. What do you mean by ionization? Already I told you what is ionization. What the ionization? What is this ionization? Removing electrons. That is ionization. Removing electrons from some other, that is known as ionization. How they are asking whether they can remove electron from others. Can alpha, beta, gamma remove electron from others? What do you think? Gamma is energy. Can gamma remove electron from others? What do you think? Gamma to bad because gamma is an energy. Yeah, penetrate vegan. They can't go and clash them. They can't remove an electron from them. The gamma is an energy, therefore ionization power is zero. Is zero. So ionization when we are speaking about ionization, just the penetration power of alpha is zero? No. I didn't say that's zero. Alpha can penetrate through small foils, right? Small foils, right? Tiny foils, foil paper is there. Can penetrate through that. But it can't penetrate through even cardboard. So penetration one is zero. Penetration will be zero. Then gamma ionization power, you should know. Gamma ionization power, gamma's ionization power is zero because it can't ionize anyone. So ionization power comes from who? Alpha and beta. So both are particles. So what you can understand, particles only can ionize others. When the mass is large, when the charge is small, the ionization is so whose ionization power is galate. How is it? When the charge is small, when the particle is large, the ionization power is small. So how the කාටද power එක? Speak, Buddha, speak. Whose ionization power is small? Alpha. Because alpha is large, alpha's charge is small. Why? Alpha has two protons. Beta has only one electron. So one electron charge two proton charge is small and alpha is size එක දන්නවනේ. Beta වඩා ගොඩාක් ලොකුයි. It's much larger than beta. So alpha's ionization power is more than beta. So when you talk about ionization power, when you talk about IP, here who comes as the hero? Alpha. Alpha රකේ නැති වුණාට මේක alpha's ionization power is very high than beta. Okay? And gamma ionization power is 0. Okay. Good. Now, subject එක ඔළුවට යනවාද ලස්සනට? Right? Now, beautifully, slowly, ලස්සනට දාගෙන යනවා. හරි. So when you're coming to a revision class, we don't teach. Revision class આવત alpha beta gamma කියලා තුනක් තියෙනවා කියලා එච්චරයි කියන්නේ. Ionization power එක එක ඒවා we don't tell in detail. ඕනනම් ඔය MCU එකට දාලා මේක හරි this is correct this is wrong ඔහොම තමයි කියන්නේ. Theory class mean what? We are making you to love the subject. Chemistry උනත් love එකක් ඉන්න ඕන. ඒකට තාම love එකක් ආවේ නැද්ද chemistry වලට ආවද? ටක්වත් ආවද? Okay. love එකක් එන්න ඕනේ. When things are getting easier love එකක් එනවා නිකන්. love එකක් එන්නේ ලස්සන subject එකක් සීරාවට. හරි. Don't compare this with your O-level chemistry. ඒක වෙන subject. Chemistry තමයි but ඒක like completely different. This one completely different. හරිද? Good. So Buddha, now එන්න මේ subject එක. Right? Ionization power එකට you can write like this. Gamma is an energy. Gamma is an energy. Gamma is an energy. Gamma is an energy. Therefore, its ionization power is 0. Therefore, its ionization power is 0. Therefore, its ionization power is 0. Next point. When the particle sizes increases, when the particle sizes increases, when the particle size increases, and the charge increases, when the particle size and the charge increases, when the particle size and the charge increases, the ionization power increases. The ionization power increases. The ionization power increases. Right. Alpha's mass is greater than beta. Alpha's mass and charge both are greater than beta. Alpha's mass and charge both are greater than beta. Right. Greater than beta. Therefore, alpha has greater ionization Therefore, alpha has a greater ionization power than beta. Therefore, alpha has a greater ionization power than beta. එකක් ගාලා ලියන්න පුතා. ලස්සනට. Right. Okay. Right. Now, Puta, in the hemium, the in the mega. Alpha beta ionization power clear. Right. You wrote this. You got one. Okay. What's the next subject? What's the next topic? Types of reaction. Right. There are two types of reaction. There are two types of reaction. Now, main part alpha, beta, gamma is okay. It was in the method. You're telling this for the next thing. There are two types of reaction, right? Two types of reaction. Two types of reaction. Under two types of reaction, Puta, the first type is known as chemical reaction. What is the first type? Chemical reaction. Chemical reaction means what happens here? Electrons will transfer. Electrons changes, neutrons and protons won't change. Which subatomic particle is changing? Electrons. Electrons changes. Again, electrons transfer one place to another place. Electron transfer will occur, plus new compounds can form. We'll say if you join carbon and oxygen, electrons will go here and there, and you will get carbon dioxide. From carbon and oxygen, you can get carbon dioxide. You are not going to get another element there. By carbon and oxygen reacting, and you are not going to get nitrogen dioxide there. So this is chemical reaction. What happens here? Electron transfer, proton and neutrons, no change. එතකොට අනිත් second type of reaction, nuclear reaction. Nucleus එකේනේ පුතා proton and neutrons are there. So if something changes happen in the nucleus only, will happen. Nuclear reaction will happen. එතකොට in chemical reaction, no changes in the nucleus. In nuclear reaction, right? In nuclear reaction, what will happen? Right? In nuclear reaction, from one element you can get another element. Again, after a nuclear reaction, boron can change to carbon. ඒක කොහොමද කියලා we'll see later. But boron is changing to carbon. It has happened. Boron has how many protons? Boron is fifth element. Therefore, it has only 5 protons. Carbon is sixth element. Therefore, it has 6 protons. Again, protons have increased. එතකොට what has happened? There are changes in the nucleus as well. ඒක තමයි මෙයාට nuclear reaction කියලා කියන්නේ. You understand the change? When you are learning, properly learn. එතකොට ලස්සනට වැඩේ කරගෙන යන්න පුළුවන්. No stress. හරි. Put number 1 chemical reaction කියලා දාන්න. Two types of reaction. Number 1 chemical reactions. Under chemical reactions, write like this. No changes in the nucleus. No changes in the nucleus. Under chemical reaction, write like this. No changes in the nucleus. Within brackets, right? Protons and neutrons. In bracket, protons and neutrons. No changes in the nucleus mean within bracket, protons and neutrons. No changes in the nucleus. The change happens by transferring the electrons. By transferring the electrons. By transferring the electrons. Write the next point. New compounds can form in chemical reaction. New compounds can form in chemical reactions. But new element does not form. But new elements not form. But new elements does not form. But new elements does not form. So example you can write this. C plus O2, CO2 කියන. Okay. Now we'll go to the second one. Second one, right? Nuclear reaction. Number 2. අනිත් පැත්ත මොකද ලියන්න එපා. Right in the same page. Number 2, nuclear reaction. Number 2, nuclear reaction. Under nuclear reaction, පුතා, write like this. Changes happen in the nucleus. Changes happen in the nucleus. Within brackets, right? Protons and neutrons. In brackets, you can write protons and neutrons. Changes will happen here. New elements will form. New elements will form. New elements will form. New elements will form. Now it is hard. Yes. Now Buddha, I will give a set of some things when මේ වගේ set එකක් දෙන්න. Okay. So you should know what is a proton. Again, normally in the මේ word set එක. Proton. What is proton? Normally proton කියන්නේ මොකක්ද? Proton means Buddha, if you take hydrogen 1 that is a proton. එහෙම නැත්නම් you can write P11. Okay. It has no neutron. Again, are there elements without neutron? Yes. Give me example hydrogen. There can be elements without neutron. Answer is correct. Hydrogen 1 no neutron. It has only proton and electron. There can be nucleus without neutron. Answer is correct. Oh, how bang are neutron නැතුව කොහොමද අපේ බොක්ක? No. නැතුව ඉන්න පුළුවන්, right? Right? Understood? Proton is okay. Electron mean? Have you write electron? E0 minus 1. එහෙම නැත්නම් beta 0 minus 1 මේ දෙක electron විදියට we are considering. And there is a thing called the positron. Positron. Positron means electron's positive charge is positron. You can make it instead of minus 1 here is plus 1. That is positron. තව එකක් තියෙනවා deuteron. මොකද්ද? Deuteron. Deuteron mean මොකද්ද මේ deuteron? Deuteron mean, can you remember in hydrogens there are 3 types of isotopes. එකක් මොකද්ද? Protium, deuterium and tritium කියලා තුනක් කිව්විල්ල. Okay, deuteron කියන්නේ H21 කියන එක. මේක තමයි deuteron. In hydrogens, deuteron only you have the neutron. Got the point? Right. If they say all the hydrogens don't have a neutron, answer is wrong. Right? Deuterons are having neutrons. Tritiums are having neutrons. Got the point? Next one, neutron. It was neutron. Neutron. How to write neutron? Neutron we can put N. Who can tell the 2 numbers? What should I put here? If you can tell this one, really smart. because you should use your brain to tell this. We can't කියන්න. Tell me what are the two numbers I should write up and down. කියන්න පුළුවන් නම් අයිබෝ. මොකද්ද ලියන්නේ? වගේ ලියමුද? What shall we write in the top? Shall we write in the bottom? හිතලා කියන්න. You can. උඩ මොකක් ලියමුද පුතා? කාටද කියන්න පුළුවන්? Just give it a try. Just give it a try. අවුලක් නැහැ. වැරදුනාට කමක් නැහැ. කියන්නකෝ. Here 2, here 1. That's your answer. තව කට්ටියට අපි chance දෙමු. වෙන කවටද කියන්න පුළුවන්? No need to discuss. ඕගොල්ලන්ට ඔළුවට එන එකක් කියන්න කමක් නැහැ. වැරදුනාට කමක් නැහැ පුතා. Even online students ඕගොල්ලොත් කියන්න පුතා. Right? Even you can put the answers in the chat box. You can send the answers in the chat box. කියන්න. මොකද්ද? What can we write? උඩට මොකක් ලියන්න පුළුවන්ද පල්ලයට මොකද්ද? Is it an answer? ඒක answer එක. තව එක. මොකක් කර කියන්න. ඔයා කියන්නේ. මොකද්ද? උඩ මොකක්ද දාමු? 0. පල්ලෙය මොකක්ද දාමු? 0. දෙකටම 0 දාමු. ඒක යාගේ answer. වෙන මොකක් කරේ? උඩත් එක යටත් එක. You have something, you have something. දැන් කියන්නේ හිතලා නියන් no nothing කියලා එහෙම කියන්නේ නියන් try එකක් දෙන්න. වැරදුනා කියන උඹලා මැරෙන්නේ නැහැ අද ගෙදර. You know. නියුට්‍රෝන් කියන්නේ මෙන්න මෙහෙම you can write. 0 නෙමෙයි. Here's here 1. Right? What we write down protons. The protons, neutron එකේ do you have protons? Do you have electrons in neutron? No. දෙකම 0. But in this number is made out of proton plus neutron. එතකොට මේකේ proton නැති වුණාට neutron is there. neutron එකට 1 දාන්න. දැන් මේ numbers no need to by heart. තේරුණාද? අර neutron mean 1 0 කියන එක no need to by heart. ඒක නිකම්ම ඔලුවට එන්න ඕනේ. Why? Then electron mean what? Electron we are writing -1 කියලා. Because normally if you write +1 it's a proton. -1 කියලා mean කරන්නේ එතන electron එක symbolize. They are symbolizing the electron. Proton කියනකොට why we wrote 1 1? Because the bottom number is made of proton. The top number is made out of proton plus neutron. Proton එකයි නම් මේකත් proton එකක්. එතන we have to write 1 1 කියන එක. Can you understand what I'm telling? ඒ වගේ don't try to by heart this. මේකට ගල් ලියා ගන්න පුතා. මේ set එක last. After this we'll discuss okay nuclear reaction set එකක් we'll discuss. අපි පොඩි break එකකට යමු. මේ first of all write this. We'll go to a break. ඒ break එක අරගෙන so we'll come back. Thanks 6:45. 15 minutes වගේ break එකක් ගමු. අරගෙන අගාලෙමු. අගල් ගන්න. This you just write under whatever you have written in the last part. Under that you can write this. Okay. Will teach you most of the answers. What's happening? Online students, please send the answers in the chat box. Don't learn passively. Right? Gather in again, muruku kaka in right? Tell the answers. Got the answer? Good. What? Ah, you wrote like that. Shape. If not, if you think this with a this one emission, some emission of some particle without an element. මොන වගේ එලි මොකක් වගේ එකක් තියෙන? How many alphas? Very good. You can write a 3 alpha emission. If not, you can write carbon also. Both are correct. One wants to write carbon. That also correct. Exactly. You can write two answers. If answer එකක් තමයි you can write carbon. C126 කියන එක you can write. Or you can write 3 alphas. එහෙම නැත්නම් තව කවුරු හරි ඉන්නවනම් they can write 3 helium. මේ තුනම හරි ඔකට. Okay? 6 deuterons. Deuteron. 6 deuterons. Deuteron 2 1 6 deuterons. Correct. Okay, මුල ගොඩාක් හිතනවානේ. ඒකට answers ගොඩාක් දාන්න ඕනේ ඒක. 6 deuterons. Very good. අන්තිමට අර හොයලා ගින් deuteron හෙව්වනේ බං. ඒක තමයි අර excellency එක. Right. හරි. Anyhow. Then I think now these things are okay. Deuteron correct good. හොඳයි. ඒක හිතුවවත් නැහැ කවුරුත් ඒ පැත්ත. Deuteron වත් පව් කියලා අරගත්තා. Right? හරි. හොඳයි. Good. හරි. now ඔය ටික හරි. දැන් ඔය තැනින් ඇල්ෆා බීටා ගැමා වල කතාව ඉවරයි. Now we are going to speak about a practical, because there were so many structures for the atom. එක එක කට්ටිය එක එක ඒවා කතා කිව්වා. First of all, Dalton කිව්වා. Dalton told, ඔබලා දන්නවා මේ කතාව. What did he tell? He said, atom is like, මොකද්ද? Atom is like a golf ball. Very good. That golf ball එකක් වගේ. And he said it's like a golf ball. එච්චරයි කිව්වේ, මොකොත් වෙන මොකොත් කිව්වේ නැහැ. It mean all the things inside the atom, inside the golf ball. ඒ කියන්නේ ඔය ඒ වෙලාවේ electron, proton, neutron කියලා කතාවක් he didn't tell. Atom is the indivisible particle and atom is like a golf ball. ඒ කියන්නේ you can't divide it further. like කුඩු පට්ටම් කරන්න බෑ. So ඌට ඔළුවට ආවේ golf ball එක. ඒත් අර golf ball එක කුඩු කරන්න බෑ. It was a Galtic ball. හරිද? Have you seen golf ball? අල්ලලා තියෙනවද? උස්සලා තියෙනවද? heavy. මේ ඔළුවට දුන්නා නම් ආයේ ඔළුව වට්ටක් කුඩු. right. So එයාට ආවේ ඒක. ඊට පස්සේ පොඩි කාලයක් යනකොට Thomson, he said what Rutherford නෙවෙයි, what Dalton told was wrong. ඌ බොරුකාරයෙක්. එහෙම කිව්වේ නෑ, right? බොරුකාරයෙක් කිව්වේ නෑ. as a respect අර කිව්වේ what Dalton found, it was not it's not 100% true because I found a subatomic particle කියලා Thomson told. මොකක්ද ඌ found කරපු subatomic particle එක? Electron. Very good. Thomson found the electron. So electron mean they have divided the atom further into subatomic particles. In atoms cannot be divided further කියන කතාව ඉතින් බොරු වුණා. It became wrong. ඒක බොරු කතාවක් වුණා. Dalton කියපු එක බොරුවක් වුණා after Thomson came. Then Thomson told, he told, දැන් එයාගෙන් කට්ටිය අහන්න පටන් ගත්තා. ඒක කොහොමද මේ this one කොහොමද මේක තියෙන්නේ? මොකට මතක් වුණේ golf ball එක. හවුද මෝ කියන්නේ? Dalton. So Thomson told, එයා හිතුවා මේ golf ball එකට නිකන් golf ball එක like he thought like a pudding. ඒ pudding එක ඇතුලේ නිකන් plums වගේ තිබ්බනම් he thought අර plum pudding එකක් වගේ. ඒ කියන්නේ he thought අර positive goal එක, positive ball එක, he thought negative particles are here and there, like plums. When you put plums are ලස්සන්ට මේ plum එක මෙතන from there 2 cm අනිත් plum එක කියලා you won't keep, and you just put some plums to the pudding. ඒ වගේ තමයි he thought this like plum, these electrons are here and there in the pudding. එහෙම එයා හිතන්න පටන් ගත්තා. ඒ කතාවත් එක්ක එයා හිතුවා subject එක හරි. ඉතින් ඒක එහෙම තමයි පොඩි කාලේකට කට්ටිය හිතාගෙන හිටියේ. Later part, with after this experiment, now Rutherford දැන් කරන්න යන experiment එකත් එක්ක Rutherford එක්ක දෙන්නෙක් join වුණා to do this gold foil experiment. ඒ කියන්නේ gold foil experiment. Excuse me. Hi guys. Now see this. Now with this experiment, lots of things gonna change again about the nuclear model. The first nuclear model was introduced by whom? Rutherford. Because others they didn't speak about a nucleus. They was just spoke about the atom. Atom කියන subject එක විතරයි they spoke. Yeah, don't need to buy hard things now. හරිද? ඒක තමයි ඔයගොල්ලන්ට mainly emphasizing. Don't try to buy hard. ඊට ඔයගොල්ලෝ හිතනවා exam එක question එකක් ආපුවා who found the first nuclear model. ඔයගොල්ලෝ හිතනවා nuclear model කියලා. එහෙම නෙමෙයි. මේ story line එක if you remember ගානටක set වෙනවා. nucleus එක තාම කවුරුත් find කරලා නැහැ. කියන්නේ Dalton උත් didn't find, Thomson උත් didn't find. ඊට පස්සේ only Rutherford came and he took two of his partners. What are those names? Geiger and Marston. He took as their partners ඒගොල්ලෝ අරගෙන මෙයා එක්ස්පෙරිමන්ට් එකක් කරා gold foil experiment එක. He did this gold foil experiment. What did he do? A experiment එකේ he took a radioactive substance. Then he emitted alpha particles. මේ තමයි experiment එක පුතා. This is මේක තමයි lead එක. මේකේ තියෙන radioactive substance. From this naturally emitted alpha particle. We do anything, a naturally emitted alpha particle. The naturally emitted alpha particle started to go from this. In making the alpha particle, remember, radioactive substance can release alpha, beta, or gamma. Sometimes all three. Some particles will release only alpha. Some particles will release only beta. Some particles will release only gamma. Some particle can release all three. So he took a substance, alpha emitting substance. Naturally alpha emitting. Naturally, alpha particles start to emit. And he sent these through a tiny, very thin gold foil. Very thin. Thin. Gold foil. Very thin gold foil. Thin. I can't highlight this. Very thin. Very thin gold foil. So when he sent through this, and he kept a screen around this. Around this, there is a screen. So if I draw the screen also, around this, there is a screen. Just imagine this entire circle is a screen. This he kept a screen. And this screen is with zinc sulfide. So you can see what this emitting particle is. Alpha is you can't see for your naked eye. Can't see for your naked eye. So this screen, he saw lots of emissions, lots of glitterings was in the straight line. He saw lots of alpha beam. The beam, this alpha beam, right? It went straight. Most of the particles. It means more than 90% of the particle went straight. Nothing happened to that. And he saw there are some particles, it deflected. These are some particles deflected. Most of the particle went straight. Some particle deflected. And he saw some other particles. I return now. Very low. Right? Low amount. Okay. So with this experiment, finally, he found now alpha mean what type of thing? A positive thing. If the positive thing going like this, it means he thought there is no obstacles. A gold foil because it's going through a gold foil. Without any obstacle, if it's going like that, so he thought that area should be empty. And he thought in an atom, most of the area is empty. That's the first thing he thought. Most of the area of an atom is empty. Most of the area is empty. Empty with second, he thought whatever went here, why they should come back? Some same charge particle should be there. No positive now. Why return positive if a person is going like that, who can turn that 180 for a positive particle? So he thought the positive particle of the atom is condensed in the middle. He came to an assumption after this experiment, right? Because the positive particle is in the middle. That's why this went and came back. So that what the nucleus is what charge? Positive charge. So where is proton? It is in the center. A nucleus, he thought like that. And whatever went closer to the nucleus, he thought it went away. So this is the experiment he did. And what has happened. This is the nucleus of the atom. This is the nucleus. This is the atom. Most of the alpha particles which came towards this atom went like this. No problem. Went like this. Dark particles went like this. Most of the part of the atom is empty. Empty. And he found whatever went closer. Whatever went closer to this. Whatever went, you can see, no? Whatever went closer to this, went with a huge deflection. Huge normally went with a deflection. Whatever closer to this, deflect. Right? Whatever went closer to this, started to deflect. And whatever went straight, whatever went straight, whatever went straight, it knocked this and came back. Can understand? Online people can see all the lines. The yellow line is online. Pink whatever went closer to that. Lanka start to deflect. Start to deflect. I hope now you can understand the subject. Then from this only finally, Rutherford thought the entire positive charge is gathered in the center. Okay, so this is Rutherford's gold foil experiment. Right. Now I have given you a diagram here. Online students. So online students, did you get the tute? Reply in the chat. What are the tute? All the online students who are online. Okay. And it cut here at the tute is in time. Others? දෙන්නෙක්ට තියෙනවා එක්කෙනෙක්ට විතරයි නැත්තේ right මොකක්ද උනේ ඒක මොකද නැති වෙන්නේ so පොඩ්ඩක් message you joined from Comrade, right? The students who said no, right? So පොඩ්ඩක් message them to send your tute. Okay, we are in charge of the tute, so they only should change. Okay. What දන්න ඉතින් කොහේ හරි මිස් එකක් වෙලා ඇති ඒක අහගන්න otherwise in vain. Right. I'll share the tute. And this right now explain Rutherford's gold foil experiment. Okay, so now we are going to learn about this, right? All right. Now first of all, Puta, මේකට දාන්න right මේකට දාන්න දාන්න ඕනේ. Explain Rutherford's gold foil experiment below that first, right? Geiger and Master assisted this. First point. Below Rutherford. Below Rutherford. Explain Rutherford's gold foil experiment. Itana body space. right? This space, online students within a space. Under that, right? Geiger and Geiger and Marsden assisted this. Geiger and Marsden assisted this. Geiger and Marsden assisted this. After that, now you can see the experiment. I have given the picture. Some are going like A. Whatever wind is going through the gold foil. Some have gone with deflection. B. I have given that. A most alpha particles travel through the foil undeflected. B you can see in B means what? Some alpha particles are deflected by small angles. Okay. Now, again, B part is some alpha particles are deflected by small angles. See again, occasionally an alpha particle travels back from the foil. Right. So under A, what should you write? Under A, you can write most of the parts of the atom, most of the parts of the atom are empty. Most of the atom are empty. Most of the atoms, most of the parts of the atoms are empty space. Are empty space. Again, they are empty. They don't have anything in it. They are empty. Second, some alpha particles are deflected by small angles. For that, you can write under that the particles came closer to the nucleus. You can under this B, you should write. Under this B, you should write. Under the B part, the particles came closer to the nucleus, felt large repulsive force, and a deflection. Third one, for C part, you can write particles traveling directly towards the nucleus. Particles traveling. So under C part, you should write this. Huh? The students are not having the you can get a screenshot of this. So you can write particles traveling directly towards the nucleus will completely reverse due to greater repulsive force. Due to greater repulsive force. Okay. Due to greater repulsive force. Okay. Now that part is fine. Okay. Now you can draw this. In the next page, you have a space. In that space, you can draw these two diagrams. Not only two diagrams, you can draw this diagram. You can show whatever coming towards the nearest. Okay, you draw this one. Okay, and you can mark this one as the nucleus and what the beautifully you can draw this. Okay, lesson draw කරන්න. we'll discuss our last week exam. Now you only have to correct that. Huh? So online students, if you have done the exam, please take that. Right? Please take that exam paper. This is known as what exam? Quick fire. A quick exams wala first paper was given last class. Not this. This was the quick fire exam 1, right? So online students, you can have a look. I'll share this with you. We'll discuss. It's very interesting. You have to put true, but very interesting. You have to correct your own answer taking a red pen. Please be honest. You can put correct because you have to write certain things here, right? Without only your knowledge will increase, right? Okay, you just correct this, okay? Correct. Okay, then I will give you your papers. Online students who have done the paper, now you have sent me a PDF. You correct that, right? Not sure. This is your right? Okay. Take. Okay. Now we'll discuss. Hurry. We'll discuss. First one. Hurry. Now we'll go one by one. Right? True or false? First one. John Dalton's nuclear model is called the golf ball model. Answer is false. Answer is false. First answer is false. True කියලා දාලා තිබුණා නම් ඒක wrong. Why that is false? It is nuclear model නෙමෙයි මොන මොඩල්ද? Atomic model. Write that word. It's atomic model. See, the interesting part of true false statement. Then you should be very, very, very intelligent to answer. Again, you should know the subject properly. අර දකින්නකොට නිකන් හරිනේ ඩෝල්ටන් උයි ගෝල්ස් බෝල් දෙකම හරි. ඩෝල්ටන් ගේ ලෝ වගේ තමයි කියන උඹලට මතක් වෙන්නේ. Right? But it's not nuclear model. Good. Who got correct for that? No one. Not a single person got the correct answer for that. Why උඹලට ඒක correct ගන්න බෑ because now you are just came from O levels. You should be very sensitive when you are in A levels. Second one. Cathode ray is a beam of electron. මොන බයයි දැන් ඔය කියන්න. Right? Cathode ray is a beam of electron. That's true. හරි ඒක හරියද? ඊට පස්සේ Millikan found the electron. තමයි මේකත් correct කරගන්න අත. ඔව් correct කරනවා මේකත් correct. Millikan found the electron. ඒ කතාව මොකද්ද? What you can tell about that? Millikan found the electron. ඒ කතාව false. ඒ කතාව false. Millikan found the electron කියන කතාව නම් false. හරි. ඊට පස්සේ next part එක පුතා මෙන්න මෙහෙම යන්නේ ඒක. Cathode ray deflect in electric and magnetic fields. Millikan found the electron කියන එක හරිද? Millikan මොකක්ද එහෙනම් කරේ? Millikan found the charge of the electron. Millikan found the electron කියන එක wrong. Then who found the electron? J.J. Thomson. අන්න ඒකත් දාගන්න. You write that. J.J. Thomson found. අනේ ඒක එන්න ඕනේ එතන. හරිද? Thomson තමයි වැඩේ කරේ. හරිද? වැඩේ කරේ J.J. Thomson නේ. Not Millikan. J.J. Thomson තමයි වැඩේ කරේ. මොන වැඩේද? Found the electron. Cathode ray deflects in electric and magnetic field. ඒක තමයි මොකද්ද? ඒක trueද? It deflects in electric and magnetic field කියන කතාව. ඒක true. Cathode ray produce only green color fluorescence. මං කියවනේ කොළ පාටින් එනවා කියලා. ඒක cathode ray produce only green color fluorescence කියන කතාව prove වෙන්න පුළුවන්ද? ඒක false. ඒ කතාව false. It can differ according to the gas. Can you hear me? Can you? කට්ටිය ලාන්න එකක් දාලා can. ඕකේ නේ පුතා. කොහොමද දාන්නේ? Can you hear me? Hello? Hello? Can you hear me? Can you hear me? I know. No. Still is it like that? Can you hear me? Yes, now okay, can hear. හරි මේ කතාව බලමු. Next statement එක පුතා they have given මොකද්ද? EM ratio ඒ කියන්නේ cathode ray produce only green color fluorescence කියලාව බොරු. It can differ according to the gas. When you put hydrogen it gives a green color. හරි. again should you by heart what are the colors what gases ඒ මොකුත් ඕනේ නැහැ නිකන් ඒ කතාව ඇති. EM ratio of cathode නෙමෙයි ඒක. cathode yes what is spelling mistake එක. Cathode rays change with the gas ඒ කතාව false. කතාව wrong. ඒක ඉතින් කිලින්ම theory part. Cathode ray travel in a straight line ඒක true. How you tell that it's travel in a straight line? Because it forms a shadow of a cross. It will form a shadow. Next thing, ozone is an element. කතාව true. ඔයාලට මම කියලා දුන්නා. Ozone, oxygen, if it by the same atoms, ඒක element කියලා කියන්න පුළුවන් නැත්නම් you can tell as a molecule also. All atoms are identical in an element. ඒ කතාව true the false the? Identical Dalton කතාව. All atoms are identical in an element කියන කතාව false. ඒ කතාව false. All atoms are identical in an element. හරි වැරද්ද දාන්න. All atoms are identical in an element is correct according to Dalton. So if I would have told Dalton said that all atoms are identical in an element, that's correct. But all atoms are identical in an element ඒ කතාව false because what නිසාද? Because isotopes. Elements, there are isotopes in the element. හරි. ඒ කතාවත් okay. එහෙනම් next එකට යමු පුතා අපි. Next කතාව මොකක්ද යන්නේ? One atom cannot convert to another atom in a reaction. ඒ කතාව false. දැන් අපි කොච්චරක් කරාද reaction? Carbon මොකද්ද nitrogen වෙනවා. හරිද? boron nitrogen වෙනවා. Different elements becoming different ඒ කතාව බොරු. Okay, one atom cannot convert to another atom in a reaction. It can convert to another atom in nuclear reaction. You write this, can convert in a nuclear reaction. Can convert in a nuclear reaction. This main part is you should write these extra points. Okay. Can convert in nuclear reaction. 10th one. 11th one, atoms are indivisible particles from holes. Subatomic particles are present. Subatomic particles are present. Subatomic particles are present. All compounds are formed with more element in a small ratio. Ekat holes. Some are there, they form in but complex ratios. Some in complex ratios. Rutherford performed gold foil experiment. Thank you කතාව but එදත් අපි කිව්වා ඔය කතාව. අලින් දවසේ under Rutherford. ඒක හරි. correct. ඒ කියන්නේ දෙකක් කතා කරන්න නෑ. Cathode rays are invisible radiation. ඒක true. Cathode rays travels at speed of light. Take a false. Closer to speed of light. Closer to speed of light, not speed of light. Hari hari දාන්න දුක හිතලා හරියට හරි දාන්න එහෙම කරන්න එපා. වැරදි නම් හරි වැරදි නම් වැරදි අර නම් හරි right? Okay. Tom found EM ratio by using a cathode with a hole. ඒ කතාව wrong. He used anode with a hole. කොහොම හරි අර cathode කියන කතාව තමයි wrong. Thomson found EM ratio by using an anode with a hole. Number 17, Goldstein found the positive charge using cathode ray tube. That's true. Goldstein only found the positive charge using cathode ray tube. And he found positive rays. EM ratio of electron is found by J.J. Thomson using CRT. CRT is the cathode ray tube. So he used a cathode ray tube. No? EM ratio. True. The number of molecules on and right sides of a balanced chemical equation must be equal. Number of molecules. Take a false. Take a false. Number of molecules won't be equal. Right? Number of atoms only should be equal. Number of molecules no need to be equal. Maybe at the end of long. 2 ozones, 3 oxygens, they at the end of 2 ozones. Molecules, they can be changed, but atoms should be. Can you understand the difference? Next thing, cathode ray ionizes. Correct. True. Thomson, that's why they are producing what rays? By ionizing gas only, they ionize hydrogen gas only, they produce canal rays. Anode rays. Right. So what is the answer for question 10? After going for 20, you're asking 10. 10, one atom cannot convert to another atom in a reaction, make a false. I said no, you can convert in nuclear reaction. A 10 statement is false for that. 21st, Thomson found EM ratio by using a code. 21st, Thomson introduced the plum pudding model. James Chadwick discovered the neutron using oil drop test. Atava false. James Chadwick discovered the neutron is correct, but he didn't use oil drop test. Who used the oil drop test? Millikan. Millikan only used the oil drop test to find charge of the electron. 23rd, electron shows particle and wave-like property. Take a true. De Broglie said that electron shows wave-like property. Take a true. Take a true. I have given that, right? I gave him De Broglie name. Stoney named the electron. Take a correct. He is only no name the current carrying part electron කියලා ඒ electron එතන තමයි name එක ආවේ. ඕනි තමයි name එක දැම්මේ. EM ratio of electron is 1.76 into 10 to the power 8 coulombs per kilogram. කතාව false. ඒක coulombs per gram. Very good. 1.76 into 10 to the power 8 coulombs per gram. ඒ kilogram කියන එක තමයි වැරදි. ඒ වැරද්ද you mark the mistake. ඒක mistake මොකක්ද කියලාත් you should know. ඒක false. Cathode rays can pass through metals. ඒක true. Yes, true. පුතා දැන් කිව්වේ cathode ray කියන්නේ electrons නේ. Electrons කියන්නේ beta rays වගේනේ. ඒතර beta rays ඇවිල්ලාද metals අස්සේ? නානේ. I said it can penetrate කියලා. Okay, cathode rays can pass through metals. Right. Adan cathode ray has a momentum, therefore it forms a shadow. Cathode ray has momentum, therefore it forms a shadow. Now, cathode rays has momentum, therefore it rotates the pedal wheel and move the pedal wheel. Shadow hadanne because it's going in a straight line. ඒ කතාව වැරදි because it's forming the shadow because it's traveling in a straight line. Momentum, it will rotate the pedal wheel and move the pedal wheel. Here, pause කියලා දෙන්න. Aston found the first isotope. What was the first isotope? Neon. Very good. What was the first isotope found by Aston? A කතාව true. Using what? What did he use for that? Mass spectrometer. Most of the element exist as isotopes. ඒ කතාවත් true. I told that. මේ කතාව කිව්වා most of the element has isotopes. ඒක true. හරි. දැන් බලන්න කොච්චරක් හරිද කියලා 30 වලින්. Check how many are correct out of 30. බලන්න පුතා. online කට්ටියක් දාන්න කොච්චරක් හරිද කියලා. ඔයගොල්ලෝ. Out of 30. Out of 30. Right. 20. 26. Very good. 20. It's been 10 wrong. You? 18. 12 wrong. Think carefully. You have to think and answer. Good. 21. 9 wrong. 22. 8 wrong. Good. Okay. Online pe කොහමද කතාව ඔයගොල්ලන්ගේ? අද උනේ ඔයගොල්ලන්ට. 19. Okay. Good. Others කොහමද? You correct? 19. හරි. ඊට පස්සේ තව ඉන්නවා 23. Very good. 19. හරි හොඳයි. Good. හැමෝම අරන් තියෙනවා ඉතින් above 18. හැබැයි you have to read it carefully when you are doing these A-level questions. So is it interesting? Not the true false is interesting. More than interesting අර හරියට වැඩේ කරගෙන යන්න ඕන ලස්සන. Okay, if you know the things properly, it will be very interesting. Right? Good. So you will have a good knowledge and your knowledge will be very thorough by answering this true false statement. Okay? So next week එකේ ready වෙලා ඉන්න අපි true false statement එකක් කරමු. Huh? Right. Okay. Get ready. You are lazy to write no? True false down. හැමදාම නෙමෙයි. Right? ඒකත් එක පැත්තක්. Right. ඒක හරි. Now පුතා next part අපි යමු එන්න මේකට. True false එක ඉවර වෙලා tute එකට ආයෙ යමු. Go to the tute. Tute එකේ තියෙනවා explain the Bohr model. එනවද Bohr කියන්නේ කවුද? Niels Bohr. Right? Niels Bohr. Now මෙහෙමනේ කතාව පුතා. Now the scene is කවුද Rutherford he told අර මෙහෙමයි nucleus එක. He told the positive charge is concentrated in the nucleus. එහෙම කතාවක් කිව්වා. But he couldn't tell මේ electron එක කොහෙද තියෙන්නේ. He thought electron is around කොහේ හරි. Electron is not in the nucleus. එයා electron ගැන කතාවක් කිව්වේ නැහැ. කවුද කිව්වේ නැත්තේ? Rutherford. He didn't tell anything related to. Then later part, Niels Bohr came and he contributed to this what model? Atomic model. Now he didn't come and contribute to the nuclear model. Yeah, වචන හරියට understand කරන්න. Even words, those words, try to take it to your head. What is nuclear model? What is atomic model? Each word important. So what is this? What did Niels Bohr say? He said these electrons rotate around the nucleus like planet rotate around the sun. Again, they also rotate in an orbit. ඔය කතාව තමයි Niels Bohr said. Okay? අපි දැන් ඕක ලියමු. දැන් ඒක එහෙම ලියමු අපි. We'll write that. We'll write it like this. Electrons rotate around the nucleus like planet rotate around the sun. මේ කතාව ඇත්තද? But Niels Bohr said, is it true? නෑ මේකත් බොරුවක් ඈ. Yeah, nowadays we don't tell electron they don't මෙහෙම rotate වෙන්නේ නැහැ නිකන් planets වගේ. Actually electrons are like they are like a cloud around the nucleus. You know, although you think atom is a circle, the රවුමක් වගේ හිතුවට පුතා it's not a circle. දැන් මේ හැමෝම කියපුවා බොරු වෙන්නේ. කොහොම කියපු කතා පොඩ there are problems. Chuttak okay, chuttak problem. Now, then Bogiano, Niels Bogiano, this electrons rotate around the nucleus like planet rotate around the sun. All level kale oku petta. ඒක තමයි පරම සත්‍ය. ඒ පරම සත්‍ය meaning සිංහල පරම සත්‍ය meaning අර ඉංග්‍රීසි වලින් මොකද කියන්නේ? It is the absolute truth. රායයන් එහෙම්ම තමයි තියෙන්නේ. අරණයන් සන්ව හිතනවා ජුපිටර් නිකන් මෙහෙම යනවා වගේ ඉලෙක්ට්‍රෝන එකක් යනවා right. ඊට පස්සේ චුන් එක යනවා වගේ. ඒක උඹලා දන්නවා ජුපිටර් නෙප්චූන් means what? Those are planets right. You have done geography no or පොඩි කාලේ right. ඊට පස්සේ තව එකක් මාස් එක යනවා වගේ මේක යනවා. තව එකක් කියන්නේ Uranus, Neptune, Pluto. Now they are saying Pluto is not there. No? So Pluto is not a it's not a planet, it's a star කියලා එහෙම කතාවක්. එහෙමයක් ආවා. Right? ඉතින් අපි geography පොඩ්ඩ චුට්ට කුංජම් we know right. So මේක අදාළ නැහැ මෙතනට right. So the subject is actually it's not happening like that. Actually what's happening, these electrons are going like amoeba. You know amoeba. Like in biology you learn something called amoeba. So it's also going like that. Electron clouds. There are so many things are there. ඒ කතාව බලමු. දැන් අපි බලමු what Bose said. Right? Bose model. Bose model එකේ මොකද්ද first thing? Electrons rotate around the nucleus like planet rotate around the sun. Next point, it travels in constant high speed. Constant high speed. පට්ට ස්පීඩ් එකෙන් යන්නේ මේගොල්ලෝ. Constant high speed to avoid the attraction of the nucleus. To avoid the attraction of the nucleus. කියන මේ පට්ට ස්පීඩ් එකකින් යනවා. ඇයි මෙහෙම පට්ට ස්පීඩ් එකෙන් යන්නේ? To avoid the attraction of the nucleus. Right? If it goes slowly, nucleus යන්න දෙන්නේ නැහැ. අදලා ගන්නවා ළඟට. Right? So you have to go quickly. පට ගාලා you have to go. එහෙම කියලා බෝ කියන්නේ හරිද? ඒ ඇත්ත කතාව නෙමෙයි. Not the truth. අපි දැන් ඉගෙන ගන්න truth එක නෙමෙයි. why are we learning this? The contribution of those scientists. යා මෙහෙම කිව්වා. Right? හරි. Next point එක ලියමු මෙහෙම. When electrons are moving to top energy level. මෙහෙම කතාවක්. ඒ කියන්නේ මෙහෙම කතාවක් තියෙනවා මේ බෝ කියන්නේ මෙහෙ වගේ සිද්ධියක්. He is telling now these electrons are in energy levels. they are තට්ටු ගයක් වගේ. so these are in levels. ඒ කියන්නේ first energy level පල්ලෙහාම තට්ටුව. right? Think like that. He is telling these are like energy levels. mainly රෝස පාට ඉන්නේ කෙල්ලෝ වගේ. This is the first energy level. ඊට පස්සේ there is another energy level. ඒ කියන්නේ these are like මෙහෙමනේ විලා go කිව්ව round නේ. උඹලට මේ line යනදම upset වගේ. will draw round circles. They say this is the nucleus. The nucleus. This is the first energy level. Okay, first and second. එක තව එක. කතයිනේ. Erase everything. Yeah. නෑ ඒක ලොකු එක. right. These are energy levels here. And Bose said that from the nucleus, this is the nucleus. He said that from a down energy, usually who has the highest energy? He'll say this is 1, 2, 3, 4. Which level has the highest energy? 1, 2, 3, 4. Which one? Highest energy in the fourth level. They're going away. Energy is high. Okay. energy is high, more than 1, 2, more than 2, 3, more than 3. So we'll say an electron who is here. Again, not in normal condition. He is telling when they get stimulated. Or normally, when someone stimulates you, or sometimes you go to the top, or when someone start to praise you, suddenly you start to give a party. Treat. Can you remember what's happening on a birthday? They start to surprise you. After the surprise, what's the next thing? You have to give a treat. Right? When they surprise you, it was you are in a hype level. Take a stimulative. ඒක දෙන්නසුව බෑ ට්‍රීට් එක. ඔයාලා සල්ලි අපරාධේ මොකක් කරන්නද? according to the number of friends you have to spend. ඇවිල්ලා බිත්තර ගහනවා, කේක් ගහනවා, නැත්නම් කාල් පිටි, වාම් පිටි, කුණු බිත්තර, right? They will attack from everything. මේ ඉතින් උඹලා hype වෙලා උඹලා treat එක දෙනවා. Happening like that no? Okay, have you got shots from bitter? You have got bitter shots on birthdays. Good. But you haven't got bitter shots. What you have got? Only cake. Sorry. Comrade. Likewise, when these electrons, when they get stimulated, what will happen? They start to travel for the top energy level. They start to travel for the top energy level. From this level, they start to travel for the top energy level. Just imagine they're coming for this level. If this electron going for this level, they should absorb energy, or they should release energy. To go from this level to this level, if they want to travel, they should absorb energy or they should release energy. What they done? They should release කරලා දෙන්නේ. මෙතන energy එක අඩුයි. එතන ඉන්න එකේ එතනට යනවා නම් do you need energy or no? He need energy. He should absorb energy and only he should travel there. මෙතන ඉන්න කෙනෙක් අඩු energy එකේ ඉන්න කෙනෙක්, if he wants to go for a higher energy level, he should absorb the energy and only he should go to that level. එතකොට here what should happen? Absorb the energy. මෙතන energy මොකක්ද වෙන්නේ? Absorption. So when this happening, energy absorb. From a lower level to higher level, when they are traveling, they should absorb the energy. Subject is clear? If it others way out, someone here is coming down. What happened? Absorb the release. They should release the energy. Why? They have more energy. When they are coming down, they should release the energy and they should reduce the energy and only coming here. So when they are coming here, what happens? What the release energy. Is it clear? Is it clear? From a lower level to higher level, if they want to go, they should absorb the energy. From a higher level to lower level, if they are coming, they should release the energy. Can you see the arrow directions? When you're drawing, you can use two colors and last time right? It was right like this. When we kataවත් ලියන්න එතන. මේව ලියන්න. ළමයි වගේ. Right. Right like this. When electrons are moving top energy level to top energy level, from bottom energy level, they should absorb energy. They should absorb energy. They should absorb energy. Next point. When the electron is moving from top energy level to bottom energy level, they should release the energy. They should release the energy. ඒ කතාව 100% clear now. Bow model is clear no පුතා. මේ according to the bow model we view this. ලස්සන්ට මේක ඇඳ ගන්න. Beautifully. කතා how about physics? Why? Why? Anyhow, now antima question again. Now, our time is 8:35. Alright. Now see the next thing, Putra. The question is, what is nucleon? What is nuclide? And what is nucleons, nuclide, isoprotons, and isomass? මේ පොඩි කතාව. Already you know these words, isn't it? Already you know? Okay. Then, okay. I said, what is normally, මේ හරියට අහගන්න. එතන අන්තිම part එක. After that, that is okay. මොකද්ද මේකේ subject එක පුතා? What's happening here? pen එක. මෙතන තියලා තියෙන්නේ මේ pen එක. Right. හරි. Now carefully observe. If you just write, we'll think sodium. We call this one as an element. මොකද්ද මේ? Element. This we call as an element. එහෙම නැත්නම් I can call this one as an atom. These both are correct word for this. But if I write the same sodium by writing numbers 23, 11 කියලා if I write, what we call for this? We call this one as a nuclide. You write same sodium with atomic number and mass number, that is a nuclide. What we call for this 11? This 11 is known as what number? Atomic number. This 23 is known as what? Mass number. This mass number, what is another name for mass number? Nucleons. What is mass number? What is atomic number, Puta? Atomic number is made out of what? Protons. This is equal to protons. Mass number is made out of protons plus neutrons. So nucleons mean what? Protons plus neutrons. So you know what is element atom, what is nuclide, what is nucleons, those things. Now okay with this diagram, right? Then write the first word nuclide. Nuclide. Word nuclide. This is the question, Puta. I mean, a question we are writing. Under nuclide, right? An element with an atomic number and a mass number. An element with an atomic number and a mass number is a nuclide. Is a nuclide. Write the next word, nucleon. Nucleon. For nucleons, right? The total number of protons and neutrons. The total number of protons and neutrons is nucleons. The total number of protons, neutrons is nucleons. මේ රග්ගල මේ ඔක්කොම ටික දාගන්න whatever here. Still I didn't write about isoprotons and isomass. Then රග්ගල මේක දාගන්නකො. රග්ගල write this. This is the answer for the 18th. 18th. Right. Done? Good. Good. All right. Now, next word. What is this iso? Iso means the meaning is same. If isoprotons mean, what does it mean? Same number of protons. The isomass mean same number of mass number. For isoprotons, I can give example like this. Oxygen 8, 16. Oxygen 8, 18. Carbon 12, 6. Carbon 13, 6. Carbon 14, 6. These all are what? Isoprotons. මෝට තව නමක් ඕගොල්ලෝ ඉගෙන ගත්තනේ O level කාලේ. Isotopes. Isotopes are isoprotons. And right next word, isoproton. The element having the elements having the same number of protons. The elements having same number of protons. Next point, isoprotons are isotopes. Isoprotons are isotopes. Isoprotons are isotopes. Alright. එතකොට isoprotons are isotopes. ඉතින් ඒකත් එක්ක අග්ගල මේක දාගන්න. You write the example. Alright. Then next one, isomass. And isomass, what should you write? And isomass, right? The elements having the same mass number. The elements having the same mass number. Okay. So isomass example I can put like this. 4018 make a 4019 make a 42. Okay. Isomass means having the same mass number. The elements having the same mass number. Lazy no chemistry. No need to remember, no need to buy hard these elements with numbers. If you know to identify make isoproton hari iso mass කියන එක, that is sufficient. මෙතනින් we'll wind up the session පුතා. එතකොට ඊළඟ week එකේ එනකොට අපි තව series ටිකක් දෙමු. So far I hope this class is very interesting. Okay, what do you say? Tell me some feedback about the class. What the හිතන්නේ? හැමෝම. Okay, what is your feedback? You can put in the chat box. Online people, physical people, all වටින් කියන්න.